Type definitions identify the correct data type for each instance of a custom control or indicator. When the data type of a type definition changes, all instances of the type definition automatically update. So suppose we have another VI which is also using this same type def. So now if I change the data type, of the type def from Boolean to numeric, then saving it will update in all instances. In other words, the data type of the instances of the type definition change in each VI where the type definition is used. However, because type definitions identify only the data type, only the values that are part of the data type update. For example, on numeric controls, the data range is not part of the data type. Therefore, type definitions for numeric control do not define the data range for the instances of the type definitions. So let's convert it into a type def. And let's create another instance, place another instance of the same numeric type def, and let's try to change the range. Let's make it from, let's say, 1 to 100. And let's make it from, let's say, 200 to 300. So this is allowed, and these these 1 to 100 and 200 to 300 are different from the type def, which is set to use the default limits of negative to positive infinity. Also, because the item names in the ring controls do not define the data type, changes to ring control item names in a type definition do not change the item names in instances of the type definition. So let's set the value to, let's say, 1, 2 and 3. So let's change it to a type def, and let's change the values to, let's say, numeric 1, 2 and 3 in the type def. And let's save this type def as so, and let's create another copy. And let's change this value to, let's say, so we have changed this from the original type def, and let's change this one also. And now let's open the original type def and see if it has been affected. And no, it is retaining its original values, while the two copies have their own individual values. However, if we change the item names in the type definition for an enumerated type control, the instances update because the item names are part of the data type. So let's choose an enum. Let's make it a type def. Let's type some values in it. And let's save it. And let's place a copy of it on the second VI. So both copies are showing the same text. So let's try and make some change in this. This instance. As you can see, there is no edit items available. Neither it is available in this properties. So there is no way for us to go and change this value other than to open up the original type def and make changes here. For example, let's change 3 to 6, and you see the VIE is broken. So if I save it, then you will see that 3 is no longer there, and I cannot make any changes to the text in the instances. An instance of a type definition can have its own unique caption. Let's say enum1, this is allowed. So let's hide the label and enable the caption and turn it to enum2, enum1 and enum2. And also, if we hide the caption and then enable the label, then we can have one label for one instance and second label for another instance. We can have so if I turn on the context help, and you can see that we have different descriptions for the different instances of the type def. Then we can have one tip, another tip, DNA, meaning they're different tip strips. We can also have one value as default type for one instance and another value as default type for the other instance. We can have different sizes. We can also have different colors or style of control or indicator. For example, if we open the type def and change it to slide and save it, the instances retain their knob appearance, knob style. So if we change the data type in a type definition, LabVIEW converts the old default value in instances of the type definition to the new data type if possible. Say for example, let's set the default value to, let's say, 12. And then let's check in the context help that this is a double data type. So let's open the type def and let's change its data type to, let's say, unsigned 32, and let's close it and save it. So LabVIEW has this VI is broken now. Let's see what LabVIEW is complaining. Type definition numeric. LabVIEW cannot update from type definition without incorrectly preserving default values. You must right click this control and select review and update from the type definition. So let's right click and review and update. So let's approve the both. He's asking, LabVIEW is asking for the two instances of the VIs. So approve it and let's apply the changes, and our default value is now set. The problem arose because in the second instance we had set the limit from 200, which did not include 12. So LabVIEW cannot preserve the instance default value if the data type changes to an incompatible type, such as replacing a numeric control or indicator with a string control or indicator. For example, let's open up this type def, numeric type def, and let's replace it with, let's say, string. And let's save it. So as you can see that from the default value of 12 we are going to an empty value. When the data type of a type definition changes to a data type incompatible with the previous data type, type definition, LabVIEW sets the default value of instances to the default value we specify in the CTL file. If we do not specify a default value, LabVIEW uses the default value for the data type. For example, if we change a type definition from a numeric to a string type, LabVIEW replaces any default values associated with the old numeric data type with empty strings. As you can see here, from 12 to empty, and from 200 in the other VI, numeric instance to empty. So let's approve both of them and apply changes. As you will see, we have an empty string. But let's open the type def. Now let's change this to another data type, for example from string to numeric. And let's set the default value for this numeric to 78. So let's see how this updates. So let's save it, and we have changed the two strings to instances to two numerics with the new updates default values applied.